Welcome to clickmyproject.com. Let's discuss on the paper Improved Nonlocal Means based on Pre-Classification and Invariant Block Matching. In this paper, they have focused on improving the denoising performance of NLM, where they have concentrated on finding reliable candidate sets. Though previous methods are adapted to provide better candidates for weighted averaging, our approach is unique in that it exploits moment invariance in pre-selection and RIBM in filtering process. This gives more reliable clustering results due to the invariant undernoise characteristics of hue moment invariance. On this basis, RIBM, rotational invariant block matching, provides the rotation invariant weight calculation within each cluster. In this paper, we propose to improve NLM by integrating Gaussian blur clustering, rotationally invariant block matching into the NLM framework. Let's discuss on data flow diagram. Consider an image and add Gaussian noise to it, and you have to estimate the noise parameters using MSE and PSNR. Then subject the Gaussian noise image to Gaussian filtering algorithm and then convert the images into patches. Hereafter you will be proceeding only with the patches. For each of the patches converted, you have to calculate hue moment features and store it in a mat file, and then you have to provide that mat file to this k-means clustering algorithm. This k-means clustering algorithm will cluster the patches into classes. That is, the patch features are clustered here. This is the pre-classification referred in the paper. And now you have to get the original noisy image to clusters using this pre-classification as a lookup table and then subject it to RIBM, that is rotation invariant block matching, and calculate the weighted average method, which is always used in NLM. And finally you will be getting a denoised image, and this denoised image is subjected to analysis such as MSE, PSNR and SSIM, where MSE stands for mean squared error, PSNR for peak signal to noise ratio, and SSIM for structural similarity index. And this analysis is carried out for original image and denoised image. Now let's see the execution of the algorithm. Regarding execution of the program, select denoise M file and press run file. This is the guide designed for improved NLM. Have to select an image. I'm selecting the first image and I'm going to add the noise level of 0.1. This is MSE and PSNR calculated for the noisy image. Now the pre-filtering process, it is pre-filtered using Gaussian filter, and this is the patch separation. The image is separated into 15 by 15 pixels. Each of the patch represents 15 by 15 pixels. The entire image size is 225 by 225. So you will be getting 225 patches, and these patches will be subjected for the next process of the iteration. It may take some time because it shows the all 225 patches. Every image which is taken as an input will be resized into 225 by 225 to separate it into 15 by 15 patches. The size can be user defined and the patch size is also user defined. Now it's going to be completed. The main intention of this algorithm is to convert the image into patches and to iterate every pixels inside denoising. So this is the patch conversion. The images are now converted to patches, and for each of the patches the features are extracted. Moment invariant feature extraction is carried on and for each of the patches the values are shown in the table. For all the 225 patches, one patch will be having 7 features. Now these 7 features will be subjected to clustering algorithm, and all the 225 patches will fall under any of this category. We have clustered the image features into 3 clusters. Now the noisy image will be converted into patches. After completion, a message box will be displayed, and now you are going to classify each of the patch and you are going to denoise it. This is the denoised image, and this is MSE and PSNR calculated. In this paper, we have proposed an improved NLM method. It applies moment invariant based on k-means clustering on Gaussian blurred image, which provides better classification before weighted averaging. Experimental research shows that clustering on moment invariant is very effective for pre-classification. The proposed algorithm can effectively reconstruct the finer details and at the same time introduce fewer artifacts than other methods. Thank you.